All right, today is the last lesson in our trig unit. And today, what we're going to be doing is called solving a right triangle. Now, this is how triangles are labeled, okay, right triangles. Notice that the capital C is always the right angle, okay? The other two angles in the triangle are always labeled capital A and capital B. The sides of the triangle are labeled lowercase a, b, and c, and we always put the side opposite the angle. So since capital C is the 90-degree angle, lowercase c is the hypotenuse. They're on opposite sides of the triangle. If I'm calling this angle A, that makes the side opposite that angle lowercase a. And since up here the angle is capital B, that makes this side over here on the opposite side lowercase b. And I could do it the other way too. C is always the right angle, and lowercase c is always the hypotenuse. But the A and the B could be on either corner. So the A might be on this side, and the B might be down here. Okay? It doesn't matter as long as these two are not the right angles. But if uppercase A is angles over here, that means I need to put lowercase a down here on its opposite side. And if this angle is capital B, that means the side opposite it has to be lowercase b. Okay, so that's how you have to orientate the letters. Okay, and then I have a couple rules that will help me. Now, solving a right triangle means that we find all 6 values in the triangle. We find all 3 angles, and we find all 3 sides. So these problems will be worth 6 points each. 1 point for each correct part of the triangle. Now, a couple things we can use to our advantage. One is that if you add up all 3 angles in a right triangle, it adds up to 180 degrees every single time. Okay? So in every right triangle, if I add up the 3 angles, it always adds up to 180 degrees. Even if it's not a right triangle, this is true. The other thing we know, and this is from the first lesson of the unit, is that the 3 sides of a right triangle have this relationship, that a squared plus b squared equals c squared. And remember, that's called the Pythagorean theorem. So I can use those 2 equations to help me find the 6 parts of the triangle. Now, the other thing we know is that we can use SOHCAHTOA if we need to find a side or an angle in a triangle that we don't have. Okay, so we can use all of this information to try to find the 6 parts of the right triangle. Okay, so using this information, we would like to solve the right triangle. This means finding all 6 parts of the triangle, all 3 angles, A, B, C, capitals, and all 3 sides, lowercase a, b, c. So follow this example below. Here's our right triangle. Okay. Now, obviously, you're always going to know one of the angles because we know this is 90 degrees. So when you're solving these problems, we usually just make a little chart with capital A, capital B, capital C, lowercase a, lowercase b, lowercase c, and we just fill these in. So C is 90 degrees automatically. We'll always know that. And then I have to give you 2 other pieces of information, okay? So in order to solve a triangle, I have to give you 3 of the answers. So if you can just identify those 3, you have half the points already. But then you have to use your other knowledge to find the other sides or angles. So C is 90. Notice I gave you this side, which is 3, which happens to be opposite of angle A, which means that 3 is lowercase a. So I write lowercase a equals 3 here. You'll also notice that I've given you the hypotenuse, which is across from capital C, so that's lowercase c. So you'll always be able to fill in 3 of these answers from the picture. Okay. So then the question now is, how do I find the other 3 missing parts of the triangle? Well, Since I've given you two of the sides, I can find the third side using the Pythagorean theorem. So that's probably the first thing I would do here. So the a is 3, so I go 3 squared. B is, I don't know that one, that's what I'm going to find, so I write b squared. And c is 5, so I write 5 squared. So 3 squared is 9, b squared is just b squared, and 5 squared is 25. Now I'm just going to solve this equation for the b. So the first thing I should do is subtract 9 from both sides. I get b squared is 16. Then to solve this, I need to take the square root of both sides, because that's the opposite of squaring, and the square root of 16 is 4. And if you can't remember those, you can get those on your calculator by using the square root symbol. I'm just saying square root of 16 is 4. So now I have b, so that would be here, and I could fill it into my chart here. Okay. Now I need the angles, the two missing angles, A and B. So one option is, let's go for angle A. And if you notice, I have all the sides. I have this, I have the opposite, I have the adjacent, and I have the hypotenuse. So I could use anything, I could use any of these, SO, CA, or TOA, to find angle A. So I like sine, let's use that one. So according to SO, sine is opposite over hypotenuse. So I say, all right, the sine of A is equal to the opposite side over the hypotenuse. And if you remember back to our lesson on finding angles, all I have to do is go sine -1 of 3/5. That'll give me the angle. So remember, sine -1 is above the sine key. So it's right there above the sine key. So I hit second sine -1, and then I do 3 divided by 5. So I get 36.86. And it's okay to round angles to the nearest degree, so make it a whole number. So it'd be 37 instead of 36.8. So I'm going to write 37. So A is 37. So now I have this angle, and I can write it in my chart, 37 degrees. Now, once you have two angles, I can use this equation up here, that the three angles have to add up to 180. So I can say, all right, 37 plus B, which I don't know what that is, plus 90 has to be 180. So what I would do is add 37 and 90. So I'll use it as a calculator. 37 plus 90 is 127. Okay, so 127 plus B is 180. And then I just subtract 127 from both sides. So I'm going to do 180 minus 127. And I get 53 degrees. So that's my second angle, 53 degrees. So now I have all 6 parts of the right triangle, and I have solved this right triangle. Now, I didn't have to use sine for this. I could have said, you know what, to find A, I want to use tangent. Then I would have said tangent A equals opposite over adjacent. And then I would have said, all right, so I have to go tangent -1 of 3/4 to get the angle. And if I did that on my calculator, of course, I would go tangent -1, which is here. So I go second, tan -1, 3 divided by 4. And you'll notice I get exactly the same answer, 37 degrees, as I got with sine. So you really have some freedom when you're solving these, because you can use sine, cosine, or tangent. You can use either equation. The 3 angles add up to 180, or the 3 sides use the Pythagorean theorem. So 2 people might solve the same triangle using different methods, but you should get the same answer. So let's try a second example. This is on the back of your notes. So here's my triangle. I've given you a prompt here for the 6 values you got to find. Notice that I didn't write in the sides, so you should do that. So C is here, that's lowercase c. Lowercase a would be on this side because it's opposite of A, and this would be lowercase b. So this time, well, we always know that uppercase C is 90 degrees, and I know that A is 30 degrees, and I know that lowercase b is 10. So I have 3 of the 6 values already. I just have to be able to identify them from the triangle. And now I need to find the missing 3. Well, anytime you have 2 angles or 2 sides, I can use one of those equations I have. Remember, my 2 equations are that the angles add up to 180 or the sides follow the Pythagorean theorem. So I'm going to use the a plus b plus c is 180 to find b. So 30 plus b plus 90 should equal 180. So 90 and 30 is 120. So you should add those together first. And then to solve for b, I would subtract 120 from both sides. And I get b is 60. So I can write that up here. B is 60. And I even like to write it in the triangle itself too. Okay. Now I have to get another side, either A or C. Let's go for this side, A. So I can use this angle, 30 degrees, and realize that A is the opposite side, and they gave me 10, which is the adjacent side. So I just have to decide, would that be so, ka, or toa? Well, opposite and adjacent is tangent. So I would say tangent of 30 equals the opposite side A over the adjacent side 10. And this is one of those easy ones to solve because all you have to do is multiply both sides by 10. And I get A is 10 times tangent 30. So on my calculator, I would type in 10 times tangent 30. And it gives me 5.77, which I'm going to round to 5.8. So that gives me lowercase a, 5.8. Now, the only other thing I'm missing is side C. Since I have 2 of the letters, the lowercase letters a and b, I could use the Pythagorean theorem and say that a squared plus b squared equals c squared. So a is 5.8, b is 10, and I'm not sure what c is, so that becomes c squared. So now I just solve this. So first thing I'm going to do is square 5.8. I get 33.64. 10 squared, that's an easy one, it's 100, equals c squared. So I add these two together, 133.69 equals c squared. And now I take the square root of both sides. So I would take the square root of 133.69, and I get 11.6. So that is my third side. So solving a right triangle, you're basically using any strategy that you can think of. These are the main 3 that I can add the 3 angles to 180. I can use the Pythagorean theorem for the sides, and I can use SOHCAHTOA and TOA anytime I want to find missing angles or missing sides. And again, 2 people might solve this differently, but you will get the same answers no matter what technique you use as long as you do it right. Please ask questions if it's confusing.